Hey guys, Mr. Milton here. Today we're going to look at proportions in triangles nodes. At the end of this video, you should be able to set up and solve proportions using the side splitter and angle bisector theorems. All right, so let's look at a review problem, something we kind of already know how to do. Okay, so they're asking us to solve for x. And remember that when we're given a problem like this, before we just solve and throw into a proportion, we want to know that the triangles are similar. And so we want to prove that the triangles are similar before we start. They give us the information that the horizontal lines are parallel. So PS is parallel to QR. And that helps us a lot because now as we look at our triangles MPS and MQR, we can see first that angle M must be congruent to itself because of the reflexive property. And then with these parallel lines, they create congruent corresponding angles. Okay. And so we know that these two triangles are similar by angle similarity. Okay. And now that we know they're similar by angle similarity, now we can focus on the proportions to solve for our variable. So an MP is x, MS is 12, MQ is x plus 7.5, and MR is 18, 12 plus 6. Okay, and now we can make our proportion corresponding sides. I'll put MP over MQ. So x over x plus 7.5 and 12 over 18, MS over MR. Okay, which gives me a proportion that I'm pretty confident works out just because we went through all the necessary steps to make sure that it did. 84, 90. Okay, subtract 12x from both sides. We get 6x equals 90. Divide by 6, we get x equals 15. Okay. And so now, by proving that our triangles are similar, finding our side lengths and setting up a proportion, we're able to find out that x was 15. All right. We're going to talk about a theorem today that kind of lets us do this with a few steps less. Okay, so it says the theorem below allows you to set a proportion in a much easier way, and this is called the side splitter theorem. And this works in all triangles. Okay, and the side splitter theorem says if a line is parallel to one side and intersects the other two sides of a triangle, intersects the other two sides, then the line divides those two sides proportionally. And proportional and proportionally, all those proportions are important words when we're talking about similarity. So as we look at our diagram again, I'll just redraw it here so I don't have to scroll up. When we saw that these two lines are parallel to each other and intersected the other two sides, this is x and this is 7.5, this is 12 and this is 6. What our side splitter theorem says is, hey, this splits the sides proportionally, so we don't really have to do the redraw triangle thing. We can just say x over 7.5 should be in the same proportion as 12 over 6. Cross multiply, 6x equals 90, divide by 6, x equals 15. So do you get the same value? Yes. Okay, a little bit easier too. All right, take a second to try this problem out. Again, we have the side splitter theorem. X over 16 should be proportionate to 5 over 10. Cross multiply, 10x equals 80. Divide by 10, x equals 8. Okay. All right, going to the next problem up top. It says, why can the side splitter theorem not be used in this triangle? So as we look at this triangle, it kind of looks like the other problems we did. But remember that our side splitter theorem can only be used when we know that we have a parallel side, two parallel sides, right? And so they haven't told us that this line's parallel, and so we can't use it until we know that. All right, so now it says, assume that the line through the middle is parallel to the third side, find the value of x. So now they're telling us, okay, this line's parallel, or treat it like it's parallel. Now that they tell us that, now we can use our side splitter theorem, and we'll set up our proportion, and it should be something like x over x plus 2 equals 2x minus 1 over x plus 4. Okay, and so we're going to cross multiply x times x plus 4 equals 2x minus 1 times x plus 2. Okay, let me distribute that all out. That's 2x squared plus 4x minus x minus 2. And I want to get everything to one side because I'm dealing with a quadratic here. So subtract 2x, or x squared, subtract 4x. Okay, that cancels out. All right, and what I'm left with is x squared minus x minus 2 equals 0. Okay, for this problem, remember that we want to find two numbers that multiply to give us c. In this case, it's -2. And add to give us b. And that's this number in here, -1. So two numbers that at the same time multiply to give us -2 and add to give us -1. And those two numbers should be -2 and +1. -2 times 1 is -2. -2 plus 1 is -1. Okay, so that works out. And so we can rewrite this as x minus 2 and x plus 1 equals 0. And from there, we use our zero product property, which says if I multiply two numbers and the answer is 0, at least one of these two numbers has to be 0. So either x minus 2 equals 0 or x plus 1 equals 0. Add 2 to both sides, x equals 2. Subtract 1 from both sides, -1. Okay. So it says find the value of x. Well, I know that it cannot be -1, right? Because we can't have a length that's -1. So 2 is our answer. All right, here's a corollary to the side splitter theorem. Remember, corollary is just something that has to follow. What is happening there? All right, corollary is just something that has to follow. Like if one thing's true, then this must also be true. So you can think of a corollary. And it says if 3 or more parallel lines intersect two transversals, then the segments intercepted on the transversals are proportional. Okay, again, you'll notice that, hey, this isn't a triangle, but it kind of looks like it would be or could be. And that's all this is saying, is that, hey, this isn't restricted to only happening in triangles, right? Even if those lines don't connect, the sides that our parallel lines intersect are still going to be proportional. Okay, so basically we'd have A over B equals C over D here, even if this doesn't happen inside of a triangle. Okay. All right, now we look at our triangle angle bisector theorem, and it says an angle bisector divides the intersected side into two segments that are proportional to the other two sides of the triangle. And so here's what you should notice. In our diagram here, we have QS as the angle bisector. We can say it bisects angle PSR, right? Because it makes these two angles congruent. Okay. Now, if we look at the side that it intersects, 8 to 5, it bisects it it divides it in an 8 to 5 ratio. And what the triangle angle bisector theorem says is that is because these sides are in that same 8 to 5 ratio. And so we can solve for any missing value by setting up a proportion and making sure that we keep our sides together. 8's on the left, x is on the left. I'll make sure they stay in the same spot, okay? 5's on the right, 6 on the right. They're in the same spot in our fraction. Okay, and so now I can cross multiply and solve. 5x will equal 48, divide by 5, and that gives us 9.6. So our x value is 9.6. Okay. And then the last problem, kind of putting both of these together, says that find the lengths of JP and TP, given that KS is 5, SQ is 3, QT is 4, and KJ is 6. Okay. And now we want to find JP, I'll call that X, and TP, I'll call that Y. Okay, so what you should notice here is that we really have side splitter and triangle angle bisector theorems happening here. As we try to find x, even though our lines are vertical, we really haven't seen vertical lines. a whole lot yet. It's still the side splitter theorem, right? Two parallel lines intersecting the other two sides of the triangle. Okay, and so we can set up our proportion as 5/3 equals 6/x. Cross multiply, 5x equals 18, divide by 5, x should equal, or JP should equal, 3.6. Okay, I'm going to do the same thing for y. Well, not really the same thing, because now we're using the triangle angle bisector theorem. I'm going to use this information. Now that I know that x is 3.6, I'm going to use that to help me out, because in our triangle angle bisector theorem says that this side is split in the same proportion as KP and KQ are. Okay, so I can say 5 plus 3 is 8 over 9.6, 6 plus 9, or 6 plus 3.6. So 8 over 9.6 should be the same as 4 over y. So cross multiply, 8 times y is 8y, 4 times 9.6 gives us 38.4. Divide both sides by 8, and that gives us 44. Just use your calculator for that. 38.4 divided by 8, 4.8. Okay, so there we have it. Side splitter theorem, triangle angle bisector theorem. Together, proportions and triangles. All right, see ya.